Hello everyone, welcome to the video lecture series of data structure. Our today's topic is 2D array examples. Hi, myself Janish Shah, your instructor. So, outlines of the today's lecture is, first we'll see that how can we calculate the memory address in row major, and then we'll see about the column major examples. Now, let's first start with the formula of row major. Students, as you know that in single dimensional array the formula is A of I is equal to base address plus I minus L multiplied by size, right? But at the time we have only one dimensional array. Right now here we have 2D arrays. As I have already taught you that in 2D array the elements are stored in two different patterns. The first one is a row major and second one is a column major. In row major, students, if this is our matrices, then the elements are stored in according to row wise, and in column major, students, the elements are stored according to the column wise, right? So here our the first example is for the row major. Fine. The formula for the row major memory address calculation is A of ij is equal to base address plus size multiplied by C minus I minus LR plus J minus LC. Okay, so there are some new terms for you. So what do you mean by the C? What do you mean by the LR? And what do you mean by LC? Let's see. First, what is I? I is the row index. I is the row index. Then J is a column index. So I and J both are clear, right? Now I is a row index, J is a column index, BA stands for base address, correct? Now the next is size. Size means size of the element, not array. Make it clear. Size means size of the element. If we have integer type of an array, then size will become 2. For floating, it will be 4, right? So now next is C. Students, C means total number of columns. But before that, I would like to talk about the LR and LC. Students, LR. Remember, in single dimensional array, L means lower bound of indexes. But right now here we have two different index. For one is for row, second one for the columns. That's why LR stands for lower bound of row and LC stands for lower bound of column. Now let's move forward. The next is UC. Students, UC stands for the upper bound of column. And what do you mean by the UR? UR stands for the upper bound of row. Now let's see what is next. Next is C. Students, C that means the total number of column. Now let's see. The C is equal to total number of column. As you know the total number, what do you mean by total number of elements in array? Single dimensional. Just remember that the total number of elements in single dimensional array R is equal to U minus L plus 1. Students, again, U minus L plus 1. U is equal to upper bound, L is equal to lower bound, and we need to add one more number. Now, so same according to that, here total number of columns. Total number of columns means UC minus LC plus 1. Okay, so UC minus LC plus 1 is equal to total number of columns. Fine. So here this is the formula for row major examples. Now let's move forward to the examples. So here the first example is, okay, just read the example or just read the problem very carefully. The example is calculate the address of B of 6, 8. Calculate the address of B of 6, 8 if the given array is B of 11, 13. So here the array is B of 11, 13. We need to calculate about the address B of 6, 8 where the base address is 1000. Fine. So students, here we have base address 1000. Wait for a minute. The array is of type integer or floating. We need to check it out. So here the array is floating type an array, right? So now we have all the data. So just write down the data. First we need to write down the I, j, then base address, then total number of columns and size. Students, what do you mean by the I? I, that means row index that you need to find it out. J, that means column index that you want to find out. So here I and j become 6 and 8 respectively. So I is equal to 6, j is equal to 8. Base address is 1000. It is already given in the problem. Then given R and C. Okay, wait for a minute. Here array is B of 11, 13. That means 11 shows total number of rows and 13 shows total number of columns. So B of 11, 13, it means total number of rows and total number of columns. So we already have C. Then array is B of 11, 13. Now just watch out the what is the exactly indexes, range of index for row and column. So here the row total number of rows are 11. That's why indexes should be from 0 to 10. See, B of 0 to 10 and B of 0 to 12. This is the range of rows and columns. Now let's see what next. Students, what we need to find it out? What we just need to find out the address. Before that, C. Let me calculate C again. C is equal to UC minus LC plus 1. What is the value of LR? Lower bound of row 0 to 10. 0 to 10. That means lower bound of row is 0. Again, lower bound of column is also 0. So C is equal to UC minus LC plus 1. That becomes 12 minus 0 plus 1 is equal to 13. Now just write down the formula. Our formula is A of ij is equal to base address plus size star C into I minus LR plus J minus LC. So just put your all the data into the formula. So here it is. The 1000 multiplied by the size of is that, as it is a floating type an array, size is 4. 4 multiplied by C. C, that means total number of columns. Total number of columns are 13 multiplied by 6 minus 0. 6, that means I, lower bound is 0. J, 8, lower bound of column is 0. Then just solve this equation. You will get your answer 1344. Now let's move forward to the next example. Students, our next example is row major. This is little bit tricky. Okay, why? Because right now here just watch the example. The example is the given array is P of minus 4 triple dot 6 and minus 2 triple dot 10. What this range? What is triple dot? I have already told you it's a range of indices. Okay, so here the row indexes is ranges from minus 4 to 6 and column from minus 2 to 10. So now what we need to find it out? Here we need to find it out the address of P of minus 1 8 and the base address is 70 and the array is of type an integer type of array. So here just write it down all the data. Okay, first I is equal to minus 1, j is equal to 8, base address is equal to 70 and size is equal to 2. Now what happens with R and C? Let's look at it out. First R, that means total number of rows. How to calculate? UR minus LR plus 1. Do we need it? No. What we need? We need total number of columns. Just calculate it. C. Capital C is equal to UC minus LC plus 1. Students, make sure here the column range is already given. So what is the exactly column range? Minus 2 to 10. So minus 2 to 10. 10 becomes your UC. Then minus 2 becomes your LC. So just put it into the formula and get the answer. The answer is 13. So here we have total number of columns 13. Now write down the formula again to calculate the address. A of ij is equal to base address plus size multiplied by into bracket C into I minus LR plus J minus LC bracket complete. Just put all the values into the formula and get the answer. Fine. So here the answer is 168. So now let's move forward to the next topic. Next topic is for formula for column major. Students, formula for column major is little bit similar to the formula of row major. If you can see here, the formula is A of ij is equal to base address plus size multiplied by First is not C. See, it directly just write I minus LR. I minus LR plus R into J minus LC. R into J minus LC. Fine. So that is the difference between the row measure and column measure formula. In row measure formula, we need to calculate total number of columns, and in column measure formula, we need to calculate total number of rows. So students, now let's see again, what do you mean by I, J and each and every terms? I, that means row index, J, that means column index, BA, that means base address, then LR, lower bound of row, LC, lower bound of column, size, that means size of the each element, then the next is capital R. Wait, capital C, that means total number of columns. Same like that, here capital R becomes total number of rows. Total number of rows is equal to UR minus LR plus 1. Now, let's move forward to the example. So, example for 2D array column measure. Calculate the address of A of 6, 3. Then the given array is A of 9, 10. So students, here array is already given. Array is A of 9, 10. That means total number of row is 9. Total number of column is 10. R and C are already there. Then we need to calculate the address about 6 and 3. I is equal to 6 and J is equal to 3. Here the array is a floating type array. That means size of the array size of the elements becomes 4, and elements are in column measure order. If in your exam paper there is no written like this, that elements are in column measure or row measure, you just need to suppose the elements are in column measure or elements are in row measure and apply the formula according to it. Okay, fine. Now let's put the data. First, I is equal to 6, J is equal to 3, base address is equal to 102, size is equal to 4, then given R and C, R is equal to 9, C is equal to 10, and array is A of 9, 10. That means range should be 0 to 8 and 0 to 9. Now, move forward. What we need to find it out? We need to find out the total number of rows. R is equal to UR minus LR plus 1. UR, that means upper bound of row. Upper bound of row is 8, and LR, that means lower bound of row, that is 0. So 8 minus 0 plus 1, it becomes also 9. Now just write down the formula. A of ij. A of ij is equal to base address plus size multiplied by I minus LR plus R into J minus LC. Fine. So here, according to the formula, we just need to put out the data. Just put the data and get the answer. Students, your answer is 234. So what is the exactly address of A of 6, 3? That is 234. Now let's take out the last example of our today's lecture. Okay, now see, read it carefully. The given array is P of minus 4, 3 and 2 to 13. So here the array is given P of minus 4, 3 and 2 to 13. That is a range of rows and range of columns. I hope you already know about this. Fine. Next is, as the elements are stored in a column measure order. So here the elements are stored in a column measure order. Now calculate the address of 36th element of the array if base address is 150. Now this is very important. Here there is no details about I and J, that what exactly row index and what exactly the column index we need to find out, but the given data is calculate the address of 36th element. Okay, so before moving forward to the I and J, just first we need to write out the given data. So here I and J are not there. Fine, then it's B, that means base address is equal to 150. Size, that means integer type of an array, so obviously size becomes 2. Then given R and C. Students, do you have R and C right now? No, you need to calculate it. Okay, fine. So here our array is P of minus 4 to 3 and 2 to 13. That means lower bound of row becomes minus 4 and upper bound of row becomes 3. Lower bound of column becomes 2 and upper bound of column becomes 13. So calculate the R and C. Here R is equal to UR minus LR plus 1, that means 3 minus 4 plus 1, it becomes 8, and total number of column, that means C becomes 12. So exactly what we get the idea that there are 8 rows and 12 columns. Okay, fine. So each column contains, suppose students, if this is our matrices, just imagine this is our matrices. Okay, this is the whole array, two-dimensional array. Then just see, this is our row indices, this is our column indices. See, this is our column indices, fine, and this is our row indexes. So let's see, just write down the row and column indexes number. Okay, students, as my row index starts from -4, I am just writing it like this: -4, then -3, -2, -1, 0. I do not need to write each and every terms, fine. And my row and column index starts with 2, so I just written like 2, 3, 4, 5, 6. Okay, see, just focus on this figure. Okay, fine. Here right now what I need to find out the 36th element. Okay, what we have 8 rows, 12 columns. Now the question coming in your mind, that the elements stored in which fashion, column major or row major? Column major, right? That means the first element should be over here, then it goes like this: first column, then second column, then third column, and then fourth column. Okay, so according to the column wise, the data element will be inserted. So now tell me, what is the 36th element? Fine, see, the first column will be filled it out with the data, that means 8 elements are there. Okay, again second, again 8 plus 8, 16. Then again third column will be filled, 8 plus 8 plus 8, 16 plus 8, 24, and then fourth column. So such like this, 8 plus 8 plus 8 plus 8, that means when your 4 columns are completely filled with data, it becomes 32 elements. Now in the fifth one, okay, so what is exactly our fifth column? See, the first column number is 2, then 3, then 4, then 5, and then 6. 6 is the index, 6 is the index, it is our fifth numbers column. Fine. So after completing 32 elements, the first element will become 33, 34, 35, 36. So this is the exactly place which is our 36th element. Fine. So now just get the I and j for it. See, I becomes -1 and j becomes 6. Okay, with this you can find out the 36th element. Now you have everything. You have I, j, base address, LR, LC, and obviously capital R. So just put all the data into the formula and get the answer. The answer becomes 220. So students, such like this we can calculate the address of element when the data elements are stored into the column major. I hope you have already understood it very well. So students, in today's lecture we learn two-dimensional array memory address calculation, one for row major and second one for the column major. If you have any doubt, then please feel free to ask me. Thank you so much.